All right, good morning, everybody. Looks like we got about 8 of you right now, assuming everybody else is sleeping in or going to watch the video later. Looks like that's what's happening, which is good. I was concerned with the low number of people, but looks like there's always about 40 views by the time the videos are posted to YouTube. So hopefully that means people are going back and watching it after the fact at least. All right, so today we're doing 8.4, last section in chapter 8. This is on parametric equations. Good morning, guys. Morning, Shane, Sean. Not really a lot to put on the board as far as cheat sheet items. It's a lot of practice. Let's see, what should it is again? Okay. So not too much for cheat sheet, but what I have on the board here, I want you guys to understand, because otherwise in chapter 9, which is what we're doing next week, you're going to go nuts. So in chapter 9, we start getting into vectors. And so we're going to learn about an I vector and a J vector. They're called unit vectors. When you're entering your answers in the WebAssign, you're going to need to put like 3i plus 4j. And if you just type I and j off your keyboard, morning, Dominic, it's not going to work. And so what you need to do, that's why I got this note here, is on your guys' little drop-down menu on the side where you can do like your square root symbols and your exponents and that kind of stuff. There's another button that says vectors, I think, or it's something like that. If you click on that, then it will give you an I and a J, and it'll look like a bolded letter I and a bold letter J. So that's what you're going to use for the homework. Otherwise, if you just type I and J, like I said, off your keyboard, it doesn't recognize it as the unit vectors, and it'll mark it wrong. So just be careful on that for chapter 9. All right. So 8.4. Let's see what you guys got here. All right, so as I told you guys the other day, when you're doing these parametric equations, when they're just something like whatever, x equals t and y equals t squared, and then you sketch it, and then you have to convert it to rectangular coordinates, it's pretty easy to do, because you're like, oh, x is equal to t, so plug this into here, so that means y equals x squared. Okay, I'm done. When they're trig equations as part of the parametric equation, you can't make those sort of substitutions. So the first one you guys had a question on is number 2. We have x equals cosine of t. Y is equal to, 5 cosine of t. X equals 5 cosine of t, y equals 6 sine of t. So the first thing we have to do is sketch this. So again, the previous example where we just have x, y, and t, we can kind of pick more or less any value of t as long as we don't have a square root or something like that we're worried about. This one, we don't want to pick numbers like 0, 1, and 2. Because 0 and 1 would be okay, or not 1, but like 2, 3, 4, 5, -2, that's not going to make any sense here. So what I want to do is pick values of t from my unit circle, and this one doesn't have any restrictions. So I'm just going to pick the values that fall on the axis. So 0, pi over 2, pi, 3 pi over 2, and 2 pi go once around the circle. Reason I do that is because at all these points, my x's and y's are either going to be 0, 1, or -1. So it'll give me nice numbers here. Otherwise, as we see in problem number 4, we have to deal with radicals, and it isn't quite so nice. But in this case, let me figure out my values for x. So I'm plugging in these values of t into here. So cosine of 0 radians is 1. 5 times 1 is 5. Cosine of pi over 2 is 0. 5 times 0 is 0. Cosine of pi is -1. -1 times 5 is -5. Cosine of 3 pi over 2 is 0, so 0. And then back to the start, cosine of 2 pi is 1 times 5 is 5. For y, same idea, but now we're plugging it into that equation. So sine of 0 is 0, so this is 0. Sine of pi over 2 is +1. 6 times 1 is 6. Sine of pi is 0. Sine of 3 pi over 2 is -1, so this is -6, and then 0 again. So if you're building a table of values, this is what you should get. Any questions on that before I move on? Why we pick those numbers, how we get those values for the table. And again, if you have a question, just go ahead and hit that exclamation points. Okay, so now let's build our graph here. So now I'm not worried about T. Oh, okay, question. Yep. Okay, that's fine. All right, so sketching these points, I'm not worried about T anymore. It's just my X and Y values. So X is 5, Y is 0. And then 0, 6. So that puts me up here. And then -5, 0, 0, -6, and back to 5, 0. So I have these 4 points, and technically there's points all along the way. And what this is going to give me is not super evident because my points are 5 and 6. But it essentially gives me what's called an ellipse. Okay, that's fine. And as we will see in chapter 11, we start dealing with ellipse and hyperbolas and parabolas. So this is an ellipse, 5 units out to the side, 6 units up and down. So that should be the picture that you get. Any questions on that before I erase my table to do the conversion? All right, so the conversion is always the issue with these guys. And as I told you, what I need to do then is think about it. Do I have anything in my trigonometry bag of tricks that had the formula that has cosine and sine? And the answer is, of course, yes. It's what? It's the Holy Grail, which is what? Sine squared of t plus cosine squared of t is equal to 1. So I want to use what I was given and substitute it into here. So do I have sine squared of t? Well, no, I don't. But can I get it? Yes, I can. How? Well, up here with my y equation, I need sine squared. I'm given sine. So what do I have to do? I have to square both sides. So I get y squared, bring the squared into both pieces. So 6 squared is 36 times sine squared of t. But I want just sine squared by itself. So I have to do what? I have to divide everything by 36. So therefore, sine squared of t is just equal to y squared over 36, because by converting these to rectangular coordinates, I want my final answer just to have either x's, y's, or numbers. That's it, no trig functions. So that means sine squared is y squared over 36. So any questions on that before I move on? All right, so the next one. I want cosine squared. I don't have cosine squared. I just have cosine by itself. So I'm just going to do the same thing again. Square both sides. I get x squared is 25 cosine squared. I want cosine by itself, so divide both sides by 25. Tells me cosine square of t is x squared over 25. And this all equals 1, and that's it. We are done at that point. We've converted this. It's all x's and y's and numbers. And again, as you'll see in chapter 11, this is the equation of an ellipse that's 5 units left and right, 6 units up or down. So any questions on that one? So that's number 2. All right, so let's move on to number 4. So number 4 is going to be the attendance problem today. So again, whoops. If you can put this problem in your take it out the door notebook for today's date, 4/9, that's this problem here. So we have x is equal to secant of t, and y is equal to tangent squared of t. But in this case, t is restricted between 0 and pi over 2. And why is that? Well, I can't choose, like in the last problem, 0, pi over 2, pi, 3 pi over 2, 2 pi, because pi over 2 and 3 pi over 2 are undefined for tangent. And so that gives me an issue there. So if I build the table the same way, now my values of t have to be between 0 and pi over 2. So it's what? It's going to be 0, and we'll use our basics. Pi over 6, pi over 4, and pi over 3. So x is secant of t, and secant of t is what? That's 1 over cosine. So if I plug my values of t in for cosine and just flip it, that's the answers I'm going to get here. So for 0, if I plug it in, cosine of 0 is 1. 1 over 1 is 1. Pi over 6. Cosine of pi over 6 is root 3 over 2. So flip that is 2 over square root of 3. Rationalize this, you get 2 root 3 over 3. So when we try to plot this, we can figure out where the points go. Pi over 4. Cosine of pi over 4 is square root of 2 over 2. Flip it is 2 over root 2. Rationalize this, just becomes square root of 2. And then pi over 3. Cosine of pi over 3 is a half. Flip a half becomes 2. So this is the values you get for the x column. Any questions on that before I do the y? All right. So for tangent, so for y, we're doing tangent of squared. Tangent squared, which remember, this just means take tangent of t and then square the value. So tangent of 0 is 0. 0 squared is 0. Tangent of pi over 6. is square root of 3 over 3. Square that becomes 3 over 9, or 1/3. Pi over 4. Tangent of pi over 4 is 1. 1 squared is 1. And tangent of pi over 3 is square root of 3. Square that becomes 3. So now if I plot this one, so our first point is 1, 0. 1 unit to the right, 0 units up or down. So that is where this graph starts, at that specific point. At pi over 6, we have 2 root 3 over 3. Well, as I told you guys, square root of 3, think of it as about 2. So if this is roughly 2, 2 times 2 is 4. So this is about 4/3. It's a little bit less than 4/3, but for our purpose, it's okay. It's about 1 1/3. So we come out 1 1/3, we go up 1/3. So it's a point somewhere around there. Our next point is square root of 2 and 1. Square root of 2 is about 1 1/2. So 1 1/2 and then 1. And our net last point is 2, 3. So 2 units up, 2 units over, 3 units up. So this thing looks like this. It's a part, it's an edge or the side of a parabola. It starts here, no arrow down at the bottom here. That's where it starts, but it goes on forever. Because even though our table ended here, technically we could keep picking values of theta or of t that get closer and closer and closer to pi over 2. It never hit it, but it'll go on infinitely. So that's the sketch you should have, just that sort of right side of part of the parabola. Does that make sense? Questions on that before we get into conversion? Okay, so our conversion then. So, just like the last problem, I had to think about, do I have any equations that have sine and cosine as part of the equation? And then I made the substitutions. So same thing here. What's my relationship, or do I have any sort of equation that involves secant and tangent? I'll let you guys try to answer that as best you can through the comment section here. What equation do I have, or what relationship do I have between tangent and secant? So I'll leave this to you guys. What relationship do I have between secant and tangent? Yep. So Stephanie has it right. It's not our holy grail, but it's close, right? It's our, I think it was the second one that we had, one of our Pythagorean identities, and that's tangent squared of t plus 1 equals secant squared of t. Does everybody remember that? Tangent squared. Yep, okay. Yep, good. So it looks like you guys remember that. So have to do the substitutions again. Tangent squared. Do I have tangent squared? Well, yes, I do. Tangent squared is y. So I just plug that in here. So this guy here tells me tangent squared is equal to y, so I just make that substitution. And then plus 1 equals secant squared. Do I have secant squared? No, I do not, but can I get it? Yes. I just square both sides. So therefore, secant squared is just equal to x squared. So technically, you could stop there. So you've converted it. It's x's and y's in numbers. So you're done. Now, if I move the 1, if I have y equals x squared minus 1. If you think back to 126 and our transformation of graphs, this is what? This is a parabola that slid down 1 unit. So if I kept drawing this thing, this went on forever, if it was a regular graph, it would look something like that, right? That's a parabola. Instead of the vertex at the origin, it slides it down 1 unit. That's what this graph gives me. But this does not give me the piece that I started with. In order to get the piece, because remember, that's what we have to do. We're converting this into a rectangular coordinate equation, but it still has to give me the same picture. So whether I use the parametric equation or if I use the rectangular equation, it still has to give me the same picture. So the only way that this equation will give me this same picture is if what? If I say that x is greater than or equal to 1 only. Then that way it's everything from here going to the right. Otherwise, if I don't put this in, this graph would give me the entire parabola, and I don't want the entire parabola. I just want from x is greater than or equal to 1. Does that make sense why we have to put that restriction in there? I think that was, let me check WebAssign here. Okay, so they also have the restriction for y as well. Once you have one, you don't really need both, but they also want the restriction for y. And what is y greater than or equal to? Well, y is greater than or equal to 0. So it's this equation, but only when x is greater than or equal to 1 and y is greater than or equal to 0. That piece there. Does that make sense to everybody? Any questions? Otherwise, we'll move on. And again, if you can put this as your attendance question for today. Okay. So the other questions you guys had were on number 6 and 9. They're pretty similar to what we just did, so I'll kind of let you guys work through those, see if you can get them. So 6, we have x equals 5 sine of t, and y is equal to 5 cosine of t. So go ahead and try that. When you get done, just let me know done. If you already have it done, I guess just tell me you're already done. Once majority of you guys have this done, then we'll work it together. While you're doing this, let me tell you a little bit about the exams. So I thought I had changed the settings. I talked with OIT on Tuesday. They walked me through how to change the settings for exam 2 so that you guys could see it. I did it for all my classes, but I talked to 126 yesterday in the afternoon, and apparently they still can't see it. So I'll talk to OIT again this afternoon, see what's going on, why it is that you guys aren't able to see that, because I do want you guys to be able to go back and see that for review if you need it. The other thing is with regards to exam 3 and the final exam. So I have a meeting tomorrow morning with the coordinator of 127 and the chair. And so we're going to lean towards is using WebAssign for the final exam. So it'll be very much like your guys' weekly assessments. It'll just be from the whole semester. So you guys will have a bunch of questions from all the different sections that we've gone over from the whole semester. So if that's what we end up doing, or that's what he ends up doing, it's his choice. But if that's what he ends up deciding to do, then your guys' exam 3 will be essentially 2 parts. I still want to have the concept questions. So I'll do that through Canvas like we had done before on exam 2. But then I'll write your exam 3 on WebAssign so that you kind of get used to it. Again, you guys, it's kind of a good deal for you guys because you've been doing the assessments all year long. So you kind of already know how to deal with the testing on WebAssign. We have a review sheet to know what to expect on this. Hopefully. So, my assumption is he's going to create this final and then we'll all have access to it so that I can copy it to my course. That's what we need to figure out. If that's what he's going to do, and that's what, we need to figure out that process there. How can he create it in his course, but then I can copy it into mine? So it should be doable, but that's one of the bridges we have to cross. Have to talk to WebAssign and see the availability of that. Okay, yeah, we'll see if we can get to that. So again, once you guys are done with this one, just let me know done. Okay, Elizabeth. So then let me ask too. Well, I guess if you guys are done, that's good. Hopefully you have it. Is it is sketching an issue, or is it just the conversion? So if you're getting stuck, is it just the conversion, or do you need me to go through the creating the table and plotting and all that as well? sketching is the hard part, or sketching is the part you can do? Okay, okay. Yeah, it is. The more of these you practice, it's like your proof problems and things like that. So it's the hard part. Okay. So what do you got there? 1, 2, 3, 4, 5. 5 of you are done. So I'll give you guys about another minute or so here. All right. So if you build a table, again, using our axes and values, you should get this combination of 5s and 0s. Oh, actually, this is -5 and this is -5. 5 zeros and -5s. So what you should end up with is a circle. So a circle of radius 5. So any questions on that? I know a couple of you said sketching was the hard part. So any questions on how to get the values or how to sketch it to end up with a circle radius 5? I know it doesn't look, it should be a circle anyways. Any questions on that? No? All right, so then the conversion. So it's the same as the first one we had. Our relation is sine and cosine. So sine squared plus cosine squared is 1. So to get sine squared, square both sides. So you get x squared is 25 sine squared. So divide both sides by 25. So sine squared is equal to x squared over 25. Cosine, same deal. It's the same numbers. So you're going to end up with y squared over 25 equals 1. Now again, remember what I told you, this equation has to give you the same picture as this. Well, if I multiply this, you could leave it here. You could finish at that point. But just to show you, if I multiply everything by 25, I get what? X squared plus y squared equals 25. So if you think back to Math 126, this is what? This is the standard form of a circle with the center at the origin and a radius of square root of 25, which is 5. So this equation gives you the exact same picture as the parametric equation. So any questions on that one before we move on? All right. So number 9. So number 9 is similar to number 4. Again, it's using secant and tangent. The only difference with this one is that it's not tangent squared, it's just tangent. And again, t is between 0 and pi over 2. So go ahead and try that one. We got here. Yep, plenty of time. So try that one. I'm going to look at the. So when I switch over like that to look at like the Canvas page, does it still keep filming or does it like black out or something for you guys? I don't want you to lose the image there. So I guess I could always check myself later on. So again, once you finish up, just go ahead and hit done. So I know you guys are done. And once most of you have it, I'll go ahead and keep filming. Okay. I assumed it did. I assumed it's just whatever the webcam is viewing, it's viewing. I just wanted to make sure it's not like losing you guys. So, okay, perfect. It's very pixelated. Okay. Yeah, I try not to do it too much. It's more so just if I'm checking. Okay, good, Kyla. If I'm checking, what do you call it? Canvas or a WebAssign. All right, Elizabeth. Hey, Dominic. Let's see if I'm done. Okay, Sean. This problem, exactly, yeah. And so again, with these problems, once you do a couple of them, you can pretty much do them all because all you can do is square one piece or don't square it. Maybe you switch them. So X is tangent, Y is secant, but they're all basically the same problem. So once you do a few of these, you're going to know how to do them all. There's not a lot of changes that can take place as far as the trig functions go. Okay, so it looks like most of you have this, so let's go ahead and work it. So again, if we build our table, and this time again, because we're restricted with t, it's 0, pi over 6, pi over 4, pi over 3. So these values are the same as the other one. So it's going to be 1, 2 root 3 over 3, square root of 2, and 2. And then y is just the values of tangent. So we're not squaring them. So it's going to be 0, root 3 over 3, 1, and square root of 3. So if I sketch this, again, we're starting at 1, 0. This one we said is about 4/3. And this one is about 2/3, roughly. So if I go 1 1/3 and then 2/3 up, puts me at that point there. This one, root 2 is about 1 1/2 and then up to 1. And then 2 units and square root of 3 is about 1 1/2. So maybe somewhere there. So kind of getting something that looks like the square root function. Since these points are so close together. Yeah, because they start to flatten off. So further we go, the more they flatten out. So any questions on that, the sketch of the picture? Let me make sure I have that right. Yeah, more or less. Okay, so then the conversion, same equation we had before, tangent squared plus 1 is secant squared. So I just have to square both of these. So tangent squared is y squared. Secant squared is x squared. So then, again, you can pretty much leave it there, but we have to put in our restrictions, which is what? X again is greater than or equal to 1. Y again is greater than or equal to 0. Because this one would actually give us what's called a hyperbola, but it's only one little piece of the hyperbola. So we want to restrict it to just x is greater than 1, y is greater than 0. Questions on that guy? All right, so that was all of our trig ones. And then the last one is number 7, which is no trig functions anymore. So we have x is 4t plus 1. Y is t plus 1/4 squared. So we want to pick some positive, pick some negative values because we're not restricted by that point. We're not picking radian measures anymore. But when we pick our values for t, kind of look at what we have here and make the numbers easy on ourselves. So this one here, whatever we pick for t, we're going to be adding 1/4 to it. So let's pick numbers that when I add 1/4 turn out to be nice numbers. So that would be what? -5/4, -1/4, 3/4, and what we got there? 7/4. Again, you could pick -1, -2, 0, 1, and 2. It's just you're going to need a calculator versus now you don't need a calculator if you have these as your values for t. So for x, if we plug this in here, plug in -5/4. So I have 4 times -5/4 plus 1. So the 4's cancel out. -5 plus 1 is -4. If I plug in -1/4, again, the 4's cancel out. This becomes -1. -1 plus 1 is 0. Plug in 3/4. The 4's cancel out. 3. 3 plus 1 is 4. Plug in 7/4. The 4's cancel out. I get 7. 7 plus 1 is 8. You get these values here, -4048 for your value for x. Any questions on that? Again, you could have picked any values you want for t. I just picked these fractions because then it gives you nice numbers here. Now plug it into here. So -5/4 plus 1/4 is -4/4, which is -1. So -5/4 plus 1/4, I have to square it. This becomes -1. -1 squared is +1. Plug in -4. -4 plus 1/4 is 0. 0 squared is 0. Plug in 3/4. 3/4 plus 1/4 is 1. 1 squared is 1. 7/4. 7/4 plus 1/4 is 8/4. 8/4 is 2. 2 squared is 4. So these would be the values you get for your table. So any questions on that? These are the values I get just because of the value for t I picked. If you had other values for t, obviously you would get different numbers. So if I try to plot this, so we have -4, +1, 0, 0, 4, 1, and 8, 4. So what I get here, even though I've only drawn 4 points, is I get a giant parabola. Any questions on that? We still need to convert it. So you can either solve this one for t and plug it into y, or solve y for t and plug it into x. The choice is yours. I'm going to solve x. We'll get, because then we're not dealing with the squared. We'll just deal with it later. So to get, for x, to get t by itself, I have to do what? Subtract 1 from both sides. So you have x minus 1 is 4t. And so then divide everything by 4. So you have x minus 1 over 4 is equal to t. So now plug this into the equation for y. You get y is equal to x minus 1 over 4 plus 1/4. The whole thing squared. So simplify this inside. They're both over 4, so I can combine the numerators. X minus 1 plus 1. I'm just left with x in the numerator. So you have y is equal to x over 4 squared, which if you simplify that is y is equal to x squared over 16. And again, that's a parabola that's really wide. So this equation matches up with what we sketched to begin with. Any other questions on that one? None? Dominic, did you get this one now? I think this was your question, if I'm not mistaken. All right. So then let me give you guys your ticket out the door. And so the ticket out the door problems, they're still review. Your exams are still going to be over these types of problems. It's just the format, whether it'll be through WebAssign or if it'll be through Canvas. But you'll still need, okay, perfect. You still need to know how to do these problems. So first one, if z1 is equal to square root of 3 plus I, and z2 is -1 plus root 3I, find the following. A, Z1 in polar form. B, Z2 in polar form. And C, Z1 times Z2. And then 2, if x is equal, if x is equal to t squared and y is equal to 1 minus t, then sketch and convert to rectangular coordinates. And when you convert the rectangular coordinates, state the domain of x. So x is restricted to what values once we graph this thing. All right, so go ahead and try those two. Again, once you guys get done, just go ahead and type done. I'll write the answers up so at least you have it. Bottom of question two. Sketch and convert to rectangular coordinates, and then state the domain of x. Yeah, if you guys have questions, or like I said, once you get done, if you just want to type done. If you guys need another Netflix suggestion, so I'm getting a lot of Netflix in here. If you haven't seen Casa de Papel, I still say that's the one, or Money Heist. That's the one you should watch. Otherwise, I saw this one the other day. It's called The Dawn Wall. It's like a documentary. It's just a one episode. So if you just need like a hour and a half study break, that's worth. If you have Netflix, it's worth watching. It's pretty cool. It's about a rock climber in Yosemite. So pretty cool story. And again, this afternoon I'll talk to OIT, see if I don't know, anybody else having that issue, or is it just Shane's connection? As I was saying, I'll try to get that exam 2 to where you guys can view it. So again, once you guys are done, just let me know, and I can give you guys the answers. I don't want to have to keep you around longer just waiting on me. Okay, Elizabeth. Okay, that's fine, Shane. So since a couple of you are done, I'll put the answers up. I'm not trying to kick you away here. Okay, Skyla. So if you keep working on it, that's fine. Kick you away here. Okay, Skyla. So if you keep working on it, that's fine. I'm not going to shut down the stream, but at least this way, if you have it and you're done, and you don't have to stick around. So the first one, you should get Z1 is equal to 2 cosine pi over 6 plus I sine of pi over 6 Second one, Z2, is 2 cosine 2 pi over 3 plus I sine of 2 pi over 3. And then Z1 times Z2, you should get 4 cosine of 5 pi over 6 plus I sine 5 pi over 6. For the second one, so you should have a parabola pointing to the right. When you convert the equation, y equals 1 minus x squared is one variation. If you just solve x for t and then plug that in, the other option is if you move the t and the y, so you get t is equal to 1 minus y, so you get x equals 1 minus y squared. So either formula would be acceptable. And then our domain of x, either of these formulas are fine, but x has to be greater than or equal to 0. So that should be the answers you have for those guys. If you're done, if you have all of those, then I'll say bye to you guys. Have a good weekend. We'll see you on Tuesday. Otherwise, as I said, we'll see you on Tuesday. Otherwise, as I said, I'm not kicking you out here. Still have about 15 minutes. So if you need to keep working this until you get these answers, or if you're stuck and you have a question, that's fine too. So wait. Oh, this freaking guy. Whoops. All right, Sean. Yep. Thank you guys. So have a good weekend. All right. Have a good weekend, Dominic. We'll see you on Tuesday. Or we'll talk to you on Tuesday, or I'll talk at you on Tuesday, I guess, technically. All right, Elizabeth. Have a good weekend. Said the video will be better in quality. What do you mean, Shane? Okay, Mark. Have a good weekend. Yeah, my guess is because nobody else is indicating they're having the troubles, it's probably your connection. So maybe if you have like if you're on Wi-Fi, that might make a difference. If you're actually plugged into the internet somewhere, maybe it'll have a little better signal strength or something. My guess is that since nobody else seems to be having the issue, it probably just has to do with your connection speed. So if you go back and watch it on regular, like on a better connection, it should be okay, I'm assuming. Again, just because nobody else has said they had an issue. Looks like everybody's dropping off here. Does anybody else have any questions on these problems? Otherwise, I'll end the live stream. But if you guys still have questions or issue, I'll hang on here. So Okay, yeah, that's fine. That would be my guess. Hopefully that resolves it. Okay, well, I guess if nobody has any other questions, I will end the stream here. See, last couple people that are still on. Have a good weekend, and we will talk to you guys on Tuesday.